Hello and welcome to our presentation on Challenge 9. Our team is called GoGreen. My name is Jack, I am the team captain. On our team we also have Lee, Alex, Mohit and Nikhil. And the problem that we had faced was given to us by HS2. They're trying to achieve net zero carbon emissions. In order to achieve this, they want to identify good practice and innovative methods to distribute across to different stakeholders. In order to do this, they need to clearly identify what projects stand out and have the lowest carbon outputs, but due to the nature of projects, it is difficult to contrast and compare them. The challenge our team faced was collating carbon data of assets on a project and develop a method to normalise them to create a benchmark on which to measure against. So to summarise, they want to reduce carbon emissions across all projects, but because of a lack of clarity of carbon performance on different types of assets, they are unable to effectively communicate carbon performance. The solution that we have was threefold: data preparation to combine all of our export files across a number of different assets, a way to then normalise our carbon emissions into a singular unit in which to measure, and then input that into a Power BI report to create engaging visuals for decision making. With the data that we'd received, we had to create a number of assumptions. We have import files and export files. The export data was the information that we were really interested in to combine that one unified data set. There was a hierarchy in which to follow, where folders A through B were different projects, and within those have these export files which have our assets and the components that build up those assets. There was a key column which was our global warming potential. In different exports, these columns were named slightly differently, but our assumption was that it was however it was named, it was this column that was our carbon performance. And to perform a standard deviation with the normalisation that we produced, we need to make the assumption that it was a normal distribution of data on that GWP per unit. The way in which we cleaned our data was through Python. It looped through all of our folders to find specific Excel files with naming conventions. In that, it combined all those files together and added a column to identify the date in which the script was ran and the folder where the file is sit. We also made the assumption that the design function name was what we were going to have as our actual asset title, and we need to make sure that that was that alongside the GWP was presented into the data. And for this to be combined into one singular file for which we can create a data set that we can put into Power BI. As part of the normalisation, we want to then input all that raw data into Power BI to then summarise the GWP across the life cycle of an asset to then output into Excel. From there, we will provide a very quick exercise through assumptions to identify the size of that actual asset, so we could then divide that size of that asset into a singular unit that we can have, which can then be potentially put at scale if that asset was then built again. We also add a RAG status on there where through that standard deviation curve, where red was a standard deviation above the mean, amber was -1 and +1 around the mean, and green was -1 below the mean. We also created a Power BI report, which I'll quickly go through now. This Power BI report, as it suggests, is meant to be quite interactive. You can see across the bottom here we have our standard deviation curves. This is across all of our asset types based off those assumptions, but we can, again, with the assumptions of what types of assets we have, get specific standard deviation curves across those particular assets, and then what those asset types may be can also provide us that some quite good granularity there as well. We also have the ability to drill through to find out a little bit more information about those particular asset types as well. So we can find what that global warming potential may be across its life cycle, and a bit more information about the assumptions that we've made about those assets. If we were to attempt this challenge again, we would probably try to start on a smaller scale and just to look to cleanse 2 files initially, confirming our methodology is suitable before we actually went to scale the files. We also wanted to do some analysis of data over time. So we would want to see another column of data, say 6 months ago compared to today, to see if we can start to develop any trends of carbon being reduced across our projects. We also would like to explore machine learning to see if any insights can be gathered as to why an asset is either good or bad based on its carbon emission reduction. When it comes to the visualizations and allowing managers to decide on what best action to take, the visuals are presented into Power BI, and through the design of the report we're able to make many different ways to interact with the data presented and filter on the different asset types to understand how we can have that reliability, understand what is a high or a low performing asset. When it comes to ensuring the reliability of the information provided in our CO2 reports, the intention of the data cleansing exercise was to be done at scale, but with the exports being slightly differently structured, and we want to future-proof the method of how these files can be combined and allowing additional assets to be analysed over time. With the assumptions that we've made and the solution to data cleansing, we have some reliability of the data presented. However, with the timescales that we're given, we're unable to test as thoroughly as we wanted to. To confirm the reliability, we'd want to work closer with the challenge owner and do some further testing and analysis with data that they can obviously do some checks on their side as well. Thank you very much.